It took our user a grueling 3 hours just to connect to the internet. 3 hours.
The OS boasts only 2 remote holes in its default installation over the span of years. Realistic assumption: all software will eventually be compromised.
So let's look at why someone would even do this to themselves. As our source material lays out, our tech adventurer wanted to leave behind operating systems like Arch Linux. The reason? They felt the ecosystem had just gotten way too mainstream. They were hunting for the ultimate technical challenge. Basically, they wanted to avoid being called a Linux LARPer, someone just role-playing as a hardcore tech user. Instead, they wanted to run an operating system that is fundamentally and historically based. When you compare the two, standard mainstream Linux often leans heavily into user convenience, right? Which, let's be honest, can sometimes lead to some serious software bloat. OpenBSD is a whole different beast. It strictly focuses on proactive security and extreme minimalism. It's built from the ground up to be lean. Plus, as our adventurer enthusiastically noted, it sports this distinctively smug pufferfish mascot affectionately known as Puffy, which honestly perfectly captures the we-know-better attitude of the OS itself. But look, the aesthetic and the attitude are really just the surface. The real objective of this journey is to figure out if this deeply secure Unix-like system, which, by the way, was first released back in 1996, can actually function as a modern daily driver. We're so used to modern computing environments just magically working right out of the box, but we often trade away our security for that ease of use in the background. The test machine here is an older ThinkPad X220, and the million-dollar question is, does this intense focus on absolute security completely wreck everyday usability?
Well, let's jump right into the very first hurdle, which turned into an immediate real-world test of patience and resourcefulness: just getting the Wi-Fi to work.
Because installing an operating system is one thing, but getting it to talk to the modern world, that's entirely different. Think about that for a second. In an era where our smartphones connect to Wi-Fi instantly, spending 3 hours just to get a basic internet ping perfectly highlights the totally uncompromising nature of the OpenBSD ecosystem.
And the fix wasn't just some quick software tweak either. It was a demanding multi-step ordeal. Step 1 involved realizing the ThinkPad's physical hardware switch actually had to be manually flipped on. Step 2 required fetching proprietary Intel firmware on a completely separate USB drive, because OpenBSD point-blank does not include it by default. And Step 3? That meant strictly verifying the firmware's cryptographic signature, the SHA-256 hash, entirely offline, just to ensure it hadn't been tampered with before the system would even let you install it.
This brilliantly illustrates OpenBSD's absolute refusal to compromise on its principles. The source specifically points out that because Intel refuses to grant free distribution rights without contractual strings attached, OpenBSD simply refuses to package the firmware. Period. If software isn't completely free of contractual limits, the operating system forces you, the user, to hunt it down and verify its integrity yourself. It is security and philosophy over convenience every single time. Now, what's really fascinating here is the core philosophy driving these incredibly strict rules. It's a meticulous, fundamentally paranoid approach to system architecture.
So, unlike standard systems that might leave everyday users open to widespread exploits, OpenBSD uses radical, proactive defenses. It splits network services by privilege. It even recompiles a uniquely randomized kernel binary on every single startup, meaning attackers literally cannot predict memory layouts. And this paranoia, it pays off beautifully. That is a staggering track record.
To really grasp that track record, we have to look at exactly how it isolates threats under the hood. OpenBSD heavily relies on the fork command. In practical terms, this means when a root network service, like OpenSSH, or even just a simple ping command, is launched, it immediately clones itself into a new child process the very second it starts. But it definitely doesn't stop there. The system then hits that cloned child process with the Chroot command. This forces the root directory of that process into an entirely empty folder. The absolute brilliance of this is that it effectively traps any potential hacker in a digital room with no doors to the rest of the machine. Even if that specific process gets completely compromised, the attacker has zero access to the broader file system. So, the obvious question is, how does a normal everyday user survive this intensely complex, lockdown environment without just breaking the system or giving up in total frustration? Well, the saving grace lies in OpenBSD's legendary Manpages. Our adventurer noted that these provided immaculate, exact documentation. By simply typing the man-k command followed by a keyword, you unlock exhaustively detailed manuals built right into the terminal. Having that localized, offline library was exactly what saved the day and helped troubleshoot that agonizing 3-hour Wi-Fi crisis we talked about earlier. All right, so with connectivity finally established, the firmware validated, and the hardcore security architecture fully appreciated, it was time to actually set up a day-to-day workflow. Rather than going with a flashy, hypermodern, generic tiling window manager, our adventurer made a really cool stylistic choice. They configured the Common Desktop Environment, or CDE. Shunning modern interfaces, this choice perfectly complemented the retro, robust nature of OpenBSD with an old-school aesthetic that just looks awesome on an older ThinkPad. But as they began installing day-to-day software, a new quirk popped up. When using OpenBSD's package manager, pkged, to install larger programs like LibreOffice, the downloads and setups felt agonizingly slow. It was noticeably more sluggish than package managers on your standard Linux distributions, which begs the question, in a system coded this meticulously, why is it so incredibly slow? Looking closely at this, the user deduced that the sluggishness isn't a bug at all. It's literally just another layer of intense security. OpenBSD meticulously verifies every single dependency required by a package before allowing it to install and run. The more dependencies a program has, the longer it takes. You are directly trading speed for absolutely uncompromised, top-to-bottom security. Yet, despite the slower installs and that brutal initial Wi-Fi hurdle, the operating system proved remarkably capable as a daily driver. It easily handled routine stuff like web browsing and rewatching anime. It worked great for creating graphic thumbnails, smoothly powered video editing software like Kdenlive for a dramatic short film, and of course, because no hardware test is complete without it, it flawlessly ran classic Doom. Ultimately, the verdict was incredibly positive. Our tech adventurer found that OpenBSD could do almost everything standard Linux could do for their specific workflow. It wasn't just functional, it provided a deeply rewarding, educational, and profoundly secure experience that actually made them want to keep using it permanently. And that brings us to the end of our journey today. We live in an era absolutely dominated by automated, bloated convenience, where your operating system tries to do literally everything for you. So this experiment leaves us wondering, are you ready to trade that automated convenience for absolute security? Is stepping into the challenging, hyper-secure, and deeply educational waters of OpenBSD your next great learning adventure?